Have you ever wondered if the universe has a cheat code? Like a built-in shortcut? Well, what if I told you that a fundamental grade school algebra trick, something you probably memorized for a test and immediately forgot, actually holds the blueprint for understanding the physical universe and, incredibly, unlocking virtually unlimited energy? Seriously, let's dive into this because it's absolutely going to change how you look at reality. But first, to understand why we even desperately need a cheat code, we've got to look at our current totally brute force approach to physics. $62.5 trillion. According to our sources, that is the estimated cost to produce just 1 single gram of antimatter using today's accelerator technology. Think about that for a second. That's roughly 2.5 times the entire GDP of the United States, just to make something that weighs about as much as a paperclip. It's literally the perfect example of how absurd and unsustainable it is to try and conquer nature's boundaries through sheer brute force. So let's get into the explainer, the universe's cheat code, from arithmetic to the particle economy. Today, we are taking a mind-bending journey from everyday math straight to the cutting edge of quantum mechanics. We're exploring this amazing framework that argues we can bypass the universe's most rigid physical barriers, not by using more power, but just by shifting our perspective. It all starts with a concept we call smart laziness. For example, imagine you have to multiply 625 by 128 in your head. Trying to calculate that directly is a messy, multi-step nightmare, right? But if you just change your view and realize that 625 is exactly the same as 10,000 divided by 16, the whole problem suddenly transforms. 128 divided by 16 is 8, and 8 times 10,000 is 80,000. Boom. By seeing the structural path, instead of wrestling with the raw numbers, massive problems suddenly become incredibly easy to handle.
And that concept brings us right to our mathematical master key, the difference of squares. To really get this, let's talk about an educational character we'll call Nano Banana. So Nano Banana was a heavily struggling day trader until he learned a super simple algebraic identity. Multiplying 1 plus x and 1 minus x always equals 1 minus x squared. In the finance world, that x squared actually represents volatility drag. Every single time the market swings wildly up and down, that mathematical drag is quietly eating your money. But by embracing smart laziness, meaning he traded less frequently and actively lowered his volatility, his x, Nano Banana minimized that drag. He completely transformed from a failing trader into a compound interest genius. He literally used a hidden algebraic structure to beat the system.
Now here's where it gets wild. That exact same structural cheat code that saved Nano Banana's portfolio, it also shapes the physical geometry of our world. Normally, proving the law of cosines requires you to navigate this absolute maze of complex trigonometry. But if you just drop one altitude line to make 2 right triangles, apply the Pythagorean theorem, and subtract the equations, a difference of squares pops up right in the middle. It's a squared minus b squared. Simply factor that out using our master key, and the entire law of cosines reveals itself in just a couple of elegant lines. It completely proves that this math trick isn't just a spreadsheet hack. It fundamentally shapes the physical geometry of reality itself. And if that wasn't cool enough, here is where Nano Banana's trading trick scales all the way up to govern the cosmos. This right here is the absolute heart of Einstein's special relativity. It's the Lorentz factor, which is what dictates time dilation as you get closer to the speed of light. And it relies on the exact same structure, 1 minus v over c times 1 plus v over c. The volatility, the x from our day trading story, is simply replaced by v over c, which is the velocity of an object relative to the speed of light. The math of a middle schooler perfectly maps onto the physics of the universe. No way, right? But, of course, there's always a catch. What exactly happens when we try to take that beautiful, elegant math and blend it with the messy, microscopic reality of the quantum realm? Well, spoiler alert, it breaks the system completely. See, in traditional physics, if you treat quantum particles as infinitely small points that have absolutely zero size, 2 particles can theoretically occupy the exact same space. The distance between them literally becomes 0. And if you remember your math classes, dividing by 0 gives you infinity. It's an error. The energy mathematically skyrockets to infinity. Think of it like leaving a digital camera shutter open while pointing it directly at the sun. The sensor doesn't just get overexposed, it physically melts. But a brilliant new framework fixes this massive glitch by applying a rigid, undeniable boundary, the speed of light. This framework is called CMQEI, which stands for Conformal Mapping Quantum Energy Integral. It was presented by Ha-Suk Yi, who can be reached at kenergy99@gmail.com. Now, the huge takeaway here is how it uses nature's absolute speed limit to create something called an event thickness. Since absolutely nothing can move faster than light, particles cannot interact in zero time or zero space. By forcing everything into this mathematically finite thickness, CMQEI prevents the equations from blowing up into infinity. It literally stops the universe from mathematically destroying itself. And understanding this breakthrough completely rewrites how we think about resources on Earth. For centuries, our whole economy has been heavy. We dig up coal, we drill for oil, we light it on fire, and then it's gone. We basically treat our fuel like a matchstick. But the future particle economy envisions something totally different. We use catalyst particles not as matchsticks, but as magnifying glasses. You don't burn a magnifying glass to start a campfire, right? You just use it to focus energy over and over and over again, without ever consuming the glass itself. This introduces the secret engine of this whole new economy, the M cycle, or catalyst repetition. It tells us that a particle's true economic value isn't about how much raw energy it holds inside, but its M cycle, meaning how many times can it repeat a reaction and unlock a natural barrier before it finally disappears. So even if you have a wildly expensive particle, if its M cycle is 1,000,000, your cost per use essentially drops to zero. So what exactly are these incredible magnifying glasses we're looking for? The sources outline a pretty fascinating particle portfolio. We're talking about everything from helium-3, which we could potentially harvest from the moon, to heavy electrons called muons, all the way up to highly theoretical particles that honestly sound like they belong in a superhero movie. Let's break these down real quick. First up, we've got helium-3. It's valued at roughly $9,000 per mole, so you might assume it's just an incredibly expensive fuel to burn in a fusion reactor. But under the CMQI framework, it's actually a master key for hacking the temperature barrier. When you mix it with helium-4, it can create environments that are colder than deep space, getting incredibly close to absolute zero. And that is the exact extreme cooling infrastructure we need to stabilize future quantum computers. It's not burning, it's controlling the environment. Okay, but what if we do want to hack the fusion barrier itself? Normally, to smash two atoms together, you're back to brute force. You need insane temperatures of 100 million degrees just to overcome their natural magnetic repulsion. Enter the muon. A muon is basically a heavier electron. By swapping a regular electron out for a muon, the atom's orbit shrinks by 200 times. It acts like this heavy, stealthy coating that completely hides the atom's repulsive charge. Because of that, the atoms just naturally drift together and fuse at much, much lower temperatures. This is the ultimate smart laziness in action. But of course, there's always an engineering catch, right? Muons only live for a mere 2.2 microseconds before they decay and vanish. That is a fleeting existence, to say the least. So the entire scientific race right now isn't actually about building bigger magnets or making hotter plasmas. It's entirely about figuring out how to increase the M cycle of these muons so they can stick around to catalyze thousands of fusion reactions before they die. And if we push this framework to its absolute theoretical limits, we reach what the sources call Pime-like particles. Now, obviously, you can't just delete mass. That completely violates the conservation of energy. But what if you could hack it? Within that tiny event thickness we talked about earlier, these theoretical particles might be able to temporarily loosen a substance's connection to the Higgs field, the field that literally gives things mass. It would be a localized mathematical loophole that tricks gravity for just a fraction of a second, without actually breaking the universe's ultimate laws. Now, trying to find these specific particles and loopholes by just doing trial and error in a lab, totally impossible. That's why the final piece of this puzzle is artificial intelligence. AI acts as a super fast prospector. It runs massive density functional theory, or DFT, simulations. It's basically playing a game of quantum Tetris at hyperspeed, testing billions of atomic blueprints to find those exact topological loopholes that hack nature's boundaries while still strictly obeying the fundamental rules of physics. When AI and the CMQEI framework finally work together to fully unlock this particle economy, the trajectory of humanity is going to absolutely explode. We'll go from being a Type 0, completely planet-bound civilization today to a future where interstellar logistics costs plummet towards zero. The math actually predicts a quantum leap to a Type 3 galactic civilization within just a few centuries. It really all ties back together so beautifully. The exact same smart laziness that allowed our trader, Nano Banana, to bypass his volatility drag using the difference of squares, that is exactly what will allow humanity to bypass the physical boundaries of the universe. It's all about finding those elegant structural workarounds, instead of just blindly relying on brute force.
So, as we stand right on the brink of this incredible shift from a heavy brute force economy to an elegant particle economy, I really want to leave you with this thought. If the cheat codes to the universe have literally been hiding in plain sight in our middle school algebra textbooks, what unexpected, everyday boundary are we going to hack next? Keep questioning, keep looking for those hidden structures, and thank you so much for joining me on this explainer.